Good afternoon, guys. Today we'll solve a few problems based on Thevenin equivalent and Norton equivalent circuits. So this is a category 1 sum. So this question is, he asked to find the power loss in 5 ohm resistance by Thevenin equivalent circuit. So to find this circuit in normal way, what you will do, you will have 1, 2, 3. You will find 3 loop equations, and you will find for I you will get I1 minus I3, and you will find current I by basing on the formula V. Power loss in the 5 ohm resistance is I square R. That is, I square is, you will find the current R, current through that 5 ohms resistance, and 5 amps. So we will get power across that 5 ohm resistance. So by normal way you will find this, but if you ask in Thevenin theorem, by Thevenin theorem, so what do you have to do? We have to find Thevenin equivalent circuit. Initially you have to find Thevenin equivalent circuit. What is the Thevenin equivalent circuit of this target element? So you will write AB terminals here. You will place this target element here. For this target element, you have to find Thevenin equivalent circuit, that is voltage source in series with resistance. Okay, so the entire circuit, this entire circuit is represented by Vthevenin and Rthevenin in this target element, this 5 ohm target element. So if you find current I, after finding this Vthevenin and Rthevenin, you will get current I. This is the methodology to find current I by Thevenin equivalent circuit. So to find Vthevenin, what you have to do, in this same circuit, for finding Vthevenin, you open that AB terminal. So this is VOC. Now we place this terminal like this. Okay, this circuit is open. That means you having this one loop and this is another loop. So finding loop currents, you will find this loop current here. This is I1 current. This is I2. So in general, from loop 1, you have I1 equal to what? So in this entire loop, you have current source here. So that I1 is represented by minus 16 amps. This is I1 equal to minus 16. By loop 1, we have I1 equal to 16 amps. Sorry, minus 16 not, only plus 16 amps. So this current is entering like this, no? This is loop. From I2, you have current source 8 amps. Loop 2, you have I2 equal to what? 8 amps. Now the question is, you got I1 and I2, but what we need, we need open circuit voltage here, VOC. So to find the open circuit voltage VOC, so we, for any circuit, if we have open circuit voltage, there is a loop, there will be a loop to find that VOC. Here if you see, this is one internal loop we have, and this is also other loop. So if you choose this loop to find VOC, the loop equation is, so equating the loop equation is very much important for VOC. Is, so starting from this element, what do we have? Minus 16 plus 2 into, we have already find I1 current. I1 plus 2 into I1 minus I2, this 2 ohms. 2 into I1 minus I2 plus, you have this element, you cover this element, you cover this element, plus VOC. So plus A terminal consisting of plus term and B is minus, plus VOC equal to 0. So for VOC equal to what? 16 minus of 2I1 minus of 2 into I1 minus I2. So substitute that I1, I2 values here. So you get 16 minus of 2 into 16 minus of 2 into 16 minus 8. You got VOC equal to minus 32. So Vthevenin is got. So if you get minus also for VOC, that is Vthevenin, you represent Vthevenin as 32 here. We got minus also, but taking the terminals is maybe different. but VOC equal to, we will keep 32. Now we will find R Thevenin. So while for R Thevenin, what I said, for finding R Thevenin, you have to turn off the independent sources. This is the same circuit you have. We will open the target element and we turn off the, so turning off the current source by opening circuit. Turning off this current source is open circuit. Turning off this voltage source is we have to short. After shorting, we have to keep the terminals. This indicates that something is turned off. So this is, will keep. Now the target element is here actually. So we have to find R Thevenin. So if you look correctly, you have, so taking the direction is important. So which direction we have to find R Thevenin? If you look like this, R Thevenin to find, this entire circuit is not connected. This open terminal, open circuited. So we have to look like this. Okay. So if you look like this, the circuit remained is 2 ohms and 1 ohm. So here the circuit, this 3 ohms, 4 ohms is not connected in the circuit. If you look like this, the circuit is connected here only. Because of this open circuit, this 3 ohms is not connected. Because of this open circuit, this 4 ohms is not connected. You remove that two elements to find R Thevenin. Now R Thevenin is what? Directly 1 in series with 2 in series with 1 ohm. So 1 plus 2, that is equal to 3 ohm. So R Thevenin equal to 3 ohm. You place that R Thevenin equal to 3 ohm. Now you can find, this is the, we got Thevenin equivalent voltage, Thevenin equivalent circuit. Now you place the circuit here, the target element. Now you will find current I. How you will find the current I? So I equal to what? By loop equation, we have minus 32 plus 3 into I plus 5 into I equal to 0. So 8I equal to what? 32. So you got current I equal to 32 divided by 8. So I equal to what? 4 ohm, 4 amps. So current is 4 amps is flowing. Is flowing. Now the power across that 5 ohms is P5 equal to what? I square R form, that equal to 4 into 4 square into 5. So that is 4 square into 5. You get 80 watt. Okay. This is the method to find in Thevenin equivalent form the power lost in 5 ohm resistance. Now we will solve other circuit. This is a 5, sum 5. In this question, I asked you to find the Thevenin and Norton equivalent terminals between AB terminals. The Thevenin equivalent between AB terminals, right? So, Thevenin equivalent of AB terminals means the Thevenin equivalent is what? V Thevenin in series with R Thevenin. This is Thevenin equivalent. Norton equivalent means Rn. This is In. So now we'll find VOC. For this circuit VOC. So to finding VOC here, what is VOC? VOC is nothing but here the voltage across this terminal and this terminal. So if you look like this, if you find the voltage across this terminal and this terminal, so this is entire block, right? So just leave about this 3 ohms and this circuit. So you do not bother about these two. While finding the VOC, if you find the voltage across 6 ohms and 2 ohms, you will achieve finding VOC. So here to find the voltage across 6 ohms, what we need? The current through that 6 ohms. And for to find the voltage across 2 ohms, you need current through the 2 ohms. We will find by loop analysis. So you will take this is one loop and this is second loop, second loop. So by loop analysis, you will find you can't keep loop here because the circuit is open. Now from loop 1, what do you have? Minus 18 plus 3i1 plus 6i1 equal to 0. So this is will get 9i1 equal to 18. So i1 equal to what? 2 amps. From loop 2, directly we have I2 equal to what? 3 amps. So now the main thing here is we want VOC here. You got I1, I2, I2. So to find VOC, here we'll get a loop equation. For VOC, we have 6 into, so this you are taking loop equation in this form. So I1 is in opposite direction, so you will take minus I1 here, plus 2 into I2 is in this direction, so you will take, we are taking this direction, so minus 2, so plus VOC equal to 0. So VOC equal to what? 6I1 plus 2 into I2, 2 into minus I2, sorry, 2 into I2. So you have I1 equal to 2 ohms, 2 amps, 6 into I2, 2 ohms, 2 amps, 2 into 3. So you will get VOC equal to 6 into 2 plus 12 plus 6, that is 18 volts. So VOC equal to what? 18 volts. Okay. Now we've got Thevenin. Now our target is to find Thevenin. So now for finding Thevenin, what is to do? We have to turn off the independent sources. So we'll short this independent source and we'll open this current source. So opening the current source, what do you have the circuit? This is 2 amps, 2 ohms. So for finding Thevenin, this is Thevenin. So if you look like this, what do you get? 3 ohm in series in parallel with 6 ohms. So for Thevenin equal to 3 parallel with 6 plus 2, that equal to 2 plus 2, that is equal to 4 ohms. So Thevenin is 4 ohm. Okay. So we will replace this 4 ohm here. So that is the Thevenin equivalent circuit of AB terminal. So Thevenin equivalent circuit AB terminal is this one. Now we will find Thevenin Norton equivalent current, Norton equivalent circuit of AB terminal. So actual circuit I am drawing again. So now again I draw the circuit. Now they are asking to find Norton equivalent circuit of AB terminal. So now what we will do, for Norton current we have to short the target terminals. This is IN, keep this current IN. Now we'll have three loops, I1, I2, I3. This is loop 1, this is loop 2 and this is loop 3. From loop 1 we have minus 18 plus 3I1 plus 6 into I1 minus I2 equal to 0. So we will get 9I1 minus 6I2 equal to 18. This is loop 1. From loop 2 we have 6 into I2 minus I1 plus 2 into I2 minus I3. This is 2 equal to 0. Solving will get minus 6I1 plus 8I2 minus 2I3 equal to 0. This is loop 3. From loop 3, this is loop 2. From loop 3 we have I3 equal to what? 3 amps. This is loop 3. Solving 1, 2, 3, what do you get? Solving 1, 2, 3, we get I1 equal to 5 amps, I2 equal to 4.5 amps and I3 as usual 3 amps. So for IN is I2. So Norton current is what? IN equal to I2. So Norton current is 3 amps. Sorry. IN equal to I2, 4.5 amps. So this is 4.5 amps. And Rn is nothing but Rn is equal to R Thevenin. So you'll open this terminal, same Rn. So to turn off the circuit, you'll short this circuit. You'll find same as usual like R Thevenin. So Rn equal to 4 ohm. If you observe carefully, now the source transformation of one equation, one sentence I have to write. The source transformation of Thevenin equivalent is equal to Norton equivalent. See, if you source transformation this is a voltage source in series with resistance. This is a practical voltage source. If the source transformation is done, so IN equal to what will happen? For source transformation, we have IN equal to what? V Thevenin by R Thevenin. So V Thevenin is 18, Rn is 4. 18 by 4 is 4.5. So by calculating directly in shorting, we'll get 4.5. In the similar way, source transformation, this voltage source is Thevenin equivalent, will get Norton equivalent. So in sums, they'll ask you to find Norton equivalent by Thevenin form. So they'll ask you to find the Thevenin equivalent and represent a Norton form. So you'll find everything similar to V Thevenin, R Thevenin and all. Now if you source transform this Thevenin equivalent, you'll get Norton circuit. Okay? Or else, if you whether to get clarify whether you got Thevenin equivalent correct or not, means you can do Norton equivalent, and if you source transform both, means you'll get clarification. Solving methodology is like this. Okay, now we'll solve. So this is based on category 1, only having independent sources. Now we'll solve other circuit based on independent and dependent sources. That is category 2. Now this is category 2 sum, which is having both dependent and independent sources. So this is basically a simple sum. Here, only main thing is observing this Vx is important. Okay. So Thevenin equivalent is what? So before I said source transformation of this voltage, this Thevenin is Norton's. So AB terminal, the circuit is not changing here. The circuit property is not changing, but voltage is transforming to current. So IN equal to what here? V Thevenin by R Thevenin. So Rn is equal to R Thevenin. So we use this here concept to find Thevenin equivalent of this circuit. So Thevenin equivalent means VOC we have to find. So initially to find VOC means what is VOC? VOC is nothing but 4 into current flowing this through that circuit. So let us assume current I here. So current I is flowing here. Okay. So you'll give a loop equation here. The loop equation is minus 6 plus 2 into I plus 5 Vx plus 4I equal to 0. Okay. So now to find current I, we have adder is Vx. So Vx is what? This is voltage dependent voltage source. To find Vx, we have internal circuit. So we have to observe here carefully. This thing is having high amount of resistance. That is high amount of infinite resistance means open circuit. So don't consider this, nothing is there here. Here voltage is there, Vx is there. That is voltage. The voltage is sum of voltage across 6 volts and 2 volts. So here to find Vx, we have minus 6 plus 2I plus Vx equal to 0. So Vx equal to what? 6 minus 2I. Okay. Substitute this Vx here. What do you get? Minus 6 plus 2I plus 5 into 6 minus 2I plus 4I equal to 0. So this, by solving this, we get 2I minus 10I plus 4I equal to 6 minus 30. That is equal to what? Minus 8 minus 4I equal to minus 24. So I equal to what? 24 by 4. That is I think 6. Yeah, 6. I equal to what? 6 amps. So we got I here. So what is the for I you have loop equation. For Vx we have this loop equation. Substituting that equation we get I. So for VOC equal to what? 4 into 6. That is equal to 24. So VOC equal to what? 24. That VOC is nothing but this is V Thevenin. So we replace that 24 volts here. Now finding R Thevenin is main criteria here. Main problem here. Why? So for finding R Thevenin, in general, what you did? You turn off the independent sources. Now, this is the independent sources you have, but this is a dependent source. You cannot turn off dependent sources here. Why? Because this dependent sources is depending on Vx. So if you turn off, neither if there is no energy source, we have the voltage here. So for this, if we turn off like this means the energy source is 0, so Vx is also becoming 0. We can't turn off that. So for that reason, will depend on this formula. We have, if you find IN, so R Thevenin equal to what? V Thevenin by IN. So finding IN is important here. We will find IN by replacing the same circuit here. Six volts. We will short here for finding IN. IN means ISC, short circuit current. This is, so now This is Vx here. Now we will find In. So now we have what? Two loops. So this is loop 1, this is loop 2. So you will get loop 1 equation and loop 2 equations. For solving loop 1 and loop 2, you will get I2 equal to In. So if you observe carefully, if you do like that, is no problem. But instead of doing that form, I am saying simply, say this 4 ohm is shorted by this AB terminals. So this means this means in this short circuit there is no resistance. If there is no resistance means high amount of current will flow. So whatever the current is here, that amount every current is flowing in this only. Current flowing this 4 ohms is 0. So for that reason we'll open this 4 ohm here. So if you see, one loop will be there here. Finding that loop is easy. So directly you will get loop equation. So now in this loop In current is flowing. So the loop equation is minus 6 plus 2 In plus 5 Vx plus equal to 0. Now for Vx we have minus 6 plus 2 In plus Vx equal to 0. So Vx equal to what? 6 minus 2 In. Substitute this Vx here. We will get minus 6 plus 2 In plus 5 into 6 minus 2 In equal to 0. So you will get 2 In minus 10 In equal to 6 minus 30. That is minus 8 In equal to minus 24. So In equal to what? 3. 24 by 8. So In equal to what? 3 amps. So you got V Thevenin and I Thevenin, I Nortons. So R Thevenin is what? V Thevenin by In. So R Thevenin is V Thevenin is 24 by 3, that is equal to 8 amps, 8 ohms. Okay. So if in this circuit, if you gave find the open circuit terminal, find the Thevenin equivalent circuit, means you will solve like this. You will draw this V Thevenin, R Thevenin, problem is over. If similarly, if you ask means to find a Norton equivalent terminal between AB, means similarly you will find V Thevenin and you will find I Thevenin. For this, now you will represent In equal to V Thevenin, R Thevenin, you will get the already value. Rn equal to, you will write V Thevenin by Rn, ISC. Okay. This completes the second category, and we'll solve another sum basing on this category only. Now this is another circuit. So this is another circuit. Now for this circuit, what is asking is find the Thevenin and Norton equivalent across the load. So here the load is represented by RL. So RL is the load here we have. So to find the V Thevenin, so what we will do here, we will open, so to find the Thevenin equivalent across the AB terminal, so to find the VOC, we will open this load terminal here. So this is VOC. Place this terminal like this. After opening this RL load, we have one complete loop here. If the loop is open, we are having one loop here. By mesh equations, by loop equation, write the loop equation. So loop equation is minus 10i plus 20i. So I is flowing here. If we open the terminal, the same current, this I current will flow. 20i plus 40i plus 50 equal to 0. So you will get 50I equal to minus 50. So current I equal to what? Minus 1 amp. Okay. Now you got current I. So VOC is what? VOC is not here having any internal loop. He is also having internal loop. Either loop you can use to find VOC. Why? Because in this loop, both loops you are having voltage sources. If you have current source here, you can't apply loop here. You are very fortunate to have voltage sources here. So we will use this loop here. So from this loop you get minus 10I plus 20I plus, so minus 10I is what? Voltage source value, current dependent voltage source value, minus 10I plus 20I plus VOC equal to 0. So VOC equal to what? 10I minus 20I, that equal to minus 10I. Substitute this I value here, minus 10 of 1. So we'll get 10 volts here. So V Thevenin is what? 10 volts. So instead of that, if you wishing to find the loop equation by this, what directly we get VOC from this loop, VOC plus 40I plus 50 equal to 0. So VOC equal to what? 40I plus 50. So you have I equal to current in minus 1. Substitute that here. So either way you got 10 volts. So don't get panic by solving this VOC. Finding this VOC is a bit difficult, you will feel absorbed. Now we got V Thevenin. Now to find R Thevenin, the same problem arises here. So we are having dependent source and independent source. So to turn off independent source is easy, but we can't turn off the dependent source. So for that reason, we'll use that Norton current. So do you find Norton current? How will you find Norton current? Simply by shorting the load terminals. Short this load terminal. This is IN. So you will having two loops, I1 and I2. Now from loop 1, what do you have? Minus 10I plus 20I1 equal to 0. Okay. Now from, if you observe carefully, this is I. So we want the equation I1, two mesh equations in I1 and I2 form, but you are having I here. I is what here? Current of I2. So we have I equal to what? I2. So substitute here. Minus 10I2 plus 20I1 equal to 0. This is loop 1. So from loop 2, you have 40I2 plus 50 equal to 0. So that I2 equal to what? Minus 50 by 40. So you get I2 current equal to minus 1.25 amps. So I1 equal to what then? Solving 1, 2, you will have currents I1, I2 as so I1, solving 1, 2, we get I1 equal to 0. Solving I1 equal to 0.625 minus I2 equal to minus 1.25. So for IN is what? IN here I1 minus I2. Solving you will get I1 minus I2 is 0.625. So IN current is 0.625. So similar then Norton RN will be, so we got V Thevenin as 10 by 0.625. Solving that you will get R Thevenin. that is 16 ohms. So we place 16 ohms here. So this is Thevenin equivalent circuit. Similarly, Norton equivalent circuit means you find iron at before you place that iron. Similarly, after finding R Thevenin is V Thevenin by IN. You will initially find V Thevenin. V Thevenin value is 10 ohms and I Thevenin value R at IN value is 0.62. Solving V Thevenin Rn, you will get IN. So here Rn is R Thevenin. Rn equal to R Thevenin. This concludes the problem of second category. Now, in the next video, I will explain about third category sums. In that video, I will explain maximum. I will explain 2 circuits. Thank you.